All right, day 3 of semester final review. No, day 4. Day 4. On 61. Yesterday we talked about matching angles or matching sides to their angles. Today we're going opposite, angles to their sides. On 61 we went shortest to longest, so what's our smallest angle? 50. What's the relationship between angles and their sides?
Across.
Straight across triangle, right? For sides, when we're labeling them, do we need 1 letter or 2 letters?
2.
We need 2. What would the 2 be? ED. Now go to your next one. What's my next biggest angle? 60. What does that match with? EF. And then 70 matches with FD. Questions on those? Just remember, relationship is across the triangle. All right, moving down, we want to state if these 3 numbers given can make a triangle. Do you remember how to do these? So we're still going to underline our longest side, circle our smaller sides. So what's our biggest side? 12. Smaller sides, circle them. Those go together. Okay, we want 11 plus 4, and then we want 12 on the other side. We want the 2 smaller sides added together to be greater than our biggest side in order to make a triangle. So this might be something you want to put on your note card. So simplify, what's 11 plus 4? 15. Is 15 greater than 12? Yes. So this would be a triangle. Now, what if I got 12 equal to 12? Would that be a triangle? No, it has to be greater than. Okay, the 2 smaller sides added together have to be greater than the bigger side. Does that make sense?
Yes.
All right. Moving on down to the next, what's up?
And if it's equal to each other?
If it's equal to each other, it's not. It has to be greater than. Looking at 65 through 68, I think there's a couple more on the back. What do these look like to you? We want to state if triangles are congruent. What pops into your mind?
Side angle, side, side, side.
Yep, all of those different properties. We had, let's write them. We had side, 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 angle, side, angle, side, angle, 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 side. There's one more. Hypotenuse leg. Good. Does order matter?
Yes.
Yes. So on 65, let's just start on one end. I'm going to start with the side. Side, angle, angle. Is that a thing? No. If it's not a thing, what do we do? Go backwards. Start on the other side. If I start with angle, angle, side, is that a thing? Yes. Does the other one match? Yes. So this would be angle, angle, side. 67, what were the 2 things that we can assume?
The middle's
Middle line's the same. What's the other one? Shared sides and shared angles, vertical angles. So these right here would be congruent to each other.
so angle, angle, side.
Right. Start on one side. If I started with the side, I'd have sides angle, angle. That's not a thing. Start on the other side. So we have angle, angle, side. Could I have... Go this way. Everyone watch what I'm about to do. Angle, side, angle. Could I have done that? Why not?
No, because there's a gap.
Right, because there's a gap. I jumped across. You cannot jump across. You have to go in order. Because there was nothing in this area. Okay? I want to look at 68. What's the... Start with things you can assume.
The middle.
Middle line. Okay? What's another thing that we see?
Right angle.
Right triangle. Which one do we check? Hypotenuse leg. Do we have a hypotenuse?
Yes.
Where's the hypotenuse always at? It's across from the right angle. Okay, we have both. Do we have a leg?
Yes.
Yes, so this one would be hypotenuse leg. Questions with those? All right. Oh, there's more on the bottom. Sorry. On these ones, it gives you the property. We have to make the property true. Okay, so start with your letters. First S, do we have a side? Yes. Do we have an angle connected to that side? Yes. We need to add another side. Where does that one have to go? It has to go on LM and EF. Why?
Because they're connected to the angle.
Yep, it has to go side, angle, side. Side, angle, side.
Yay.
Order matters. Questions with those? Which one of those should be your favorite? Side. Moving on to... Okay. Any questions on those properties before I move on? All right, couple more we got to look at. We got to write a rule to describe each transformation. Between those two pairs right there, what's happening?
They're being moved.
How?
With numbers.
Genius.
Think differently. What's happening between those two shapes on 73?
They're mirrored.
They're mirrored, right? What do you mean by that?
They're mirrored on the y-axis.
It's like flipped, right? So G, we notice G is here. It's flipping over that y-axis. So it's a reflection over that y-axis. Okay? To check, G is 1 away from that line, and G prime is 1 away from that line. Check W. W is 1, 2, 3 away from that line. The other W is 1, 2, 3 away. This would just be y-axis. Y-axis reflection. So on 74, where do they reflect?
X-axis.
X-axis.
The polygons, yeah.
Yep. Any questions before we do those last couple?
No.
All right. How do we write the names of polygons?
Count sides.
Count the sides. So we have 1, 2, 3, 4, 5, and 6.
Pentagon.
What is it?
Hexagon.
Hexagon. If you have noticed already, some of you have, I wrote them up here for you. That's a good thing to put on your note card if you get it. Or right now, put it on your review. Okay, 76, how many sides do we have?
Pentagon.
5, and that is a pentagon. So everyone needs to write these 10 things on your note card, and I will move out of the way. Is there any questions on anything we went over today?
No.
All right.
Is that it?